I think we can start now.
Yeah, I think I can take it.
Yeah?
Yeah.
Muscle Meadows? Hello. All right. So, objective 7, analyzing quadratics. Quick crash course on this, all right? So, I want you to think of quadratics in 3 different forms. This is a new marker. This is supposed to be a new marker. Look at this.
Got from Staples,
what a
I
bad
bet.
new marker.
Probably from Staples.
Oh my goodness. All right. So 3 forms. All right. So our first 2 forms you're familiar with. We have standard form. We have factored form. And new addition, vertex form. All giving us valuable information about the quadratic itself. All right? So we're going to start with the quadratic I've asked you to graph in Desmos, which is x squared minus 6x plus 8. All right? We can sketch a quick graph over here what this looks like. Let's take a look at some key features. Give me some key features. What are some things you're noticing about it? It's got a blankety blank. Where? What are some key features?
Under the doorknob.
Under the God, Jack. All right. Key features. I'm talking. What do I mean by key features? Key features are what?
Also above the doorknob.
Y-intercept. What's the y-intercept? Come on, Jack. Y-intercept is 8. 1, 2, 3, 4, 5, 6, 7, 8.
B.
All right. So we are like, hey, right here. That 8 tells us the y-intercept, right? Okay. Got it. Other important features? Go ahead.
6x.
6x.
Negative 6x.
How is that an important feature to my graph?
Because it determines the length one or something.
What other key feature you see, Joshua? We gotta keep it rolling. We're on video right here. Look at Desmos. Look at that. When I say key feature, I mean an important part of your graph. All right, key feature, important part of your graph. Back to Joshua.
The x squared.
The x squared. What does the x squared determine?
Where it's going up or down.
Very good. This is a positive shape. X squared, right? Remember last semester I tell you, give me your best parabola. Go like this right here. All right. Very good. All right. It's a parabola. Determines my shape. I have a positive coefficient, so this is positive x squared. It means I expect for this to be looking like this. But you're missing probably the most important feature of a quadratic. What is the most important feature of a quadratic? We went over it multiple times. What is it, Octavio? The most important feature of quadratics are the quadratics what? X-intercept. Thank you, Maggie. Y'all whisper. You're going to be loud so you can hear yourself in the video. All right. 1, 2, what is it at? 2 and 4. 2 and 4. Very good. Now, does anything about the equation give us a clue about the x-intercepts? Like, could you have looked at this equation and you're like, well, I know the x-intercepts. Very good. We need to pass into another form in order for us to understand x-intercept. So, as far as how helpful is this form, that's pretty much it. We know the slope is positive and we know it's y-intercept. Other than that, we should probably use a different form. So Maggie says, let's go on to factored form. All right? Factored form means that I'm going to take x squared minus 6x plus 8, and I am going to turn it into a product of 2 linear factors. All right? Which means I'm going to find a linear function right here, multiplied by another linear function that is going to give me this quadratic expression. At this point, it's an expression. I should probably put it in function notation. F of x. All right, f of x. Now, factoring. We will do it in different ways. How do you factor? Someone mentioned a box. You like to use the box? This is fantastic. Said x squared, your leading coefficient. All right, leading term goes in the top left. Your y-intercept goes in the bottom right. Now you find factors. What 2 factors will multiply to give me x squared?
X and X.
X times x. And what two factors can multiply to give me 8? Am I looking for any two numbers that multiply to 8?
It's also going to be 6x.
Very good. I need two numbers that multiply to 8, but also their sum needs to be negative 6. What would this say about the two numbers?
It has to be negative.
One has to be negative? If one is negative, what does the other one have to be so I can get a positive product? They both have to be negative. Very good, Salvador. All right, so x minus a number and x minus a number. What are those two numbers?
2 and 4.
2 and 4, right? Okay, so x minus 2, x minus 4. I multiplied, I got negative 2x. I multiplied here, I got a negative 4x. I combine these, and that gives me my negative 6x. Plus 8. Very good. So my factor form is x minus 2, x minus 4. All right? So how is factor form actually helpful? Now that I know the factors, I actually now can tell what the x-intercept, or the zeros, right? So x equals 2 is a 0. X equals 4 is a 0. All right? And I know this from the factors that are above. Okay? Very good. And that right there is basically a review of what happened last semester. I can take standard form, I can analyze it a little bit, but then I start looking more at factors form. All right? Because factors form always reveals the zeros for me. Okay? Now, moving on to vertex form. There is a key feature in this function that we have not yet talked about. Well, we mentioned it last semester, but we haven't mentioned it today. All right, Jack?
Where the tippity top or biddly bottom of the graph.
Very good. And in other words, the tippity top or bibbity bottom is known as the vertex. All right, this guy right here. I forget, I gotta throw this marker away. All right, we are talking this guy. All right, I think we mentioned it as a turning point last semester. All right, the vertex is the turning point. All right, go ahead and check on Desmos. What exactly is the location of that turning point? 3, -1. So my sketch looks about right. 3, -1. All right. There is a way for you to turn your standard form into vertex form. And it's very simple, actually. All right. But this goes standard into vertex. Okay. That's how we're going to usually do it. All right. Watch and learn. If I have a function, if my function is x squared minus 6x plus 8, I'm going to do a couple of things. All right. A couple of cool things. Well, first of all, I am going to, you know what I'm going to do? I am going to add 9 to that function. But adding 9 to that function makes it a completely different function, so you know what? I'm going to subtract 9 as well. Right? So that means that I've essentially done nothing to it, right? And your question might be, why 9? Why 9? We'll talk about it briefly. Let's look at what happens if I have that, though. Because it's x squared minus 6x plus 9, I can go right here to the side, and I can try to factor that. X squared plus 9, need for these to combine to give me -6, so that's x minus 3 times x minus 3, isn't it? That would give me this guy. And you know what? I'll put it in parentheses just so we know that we're dealing with it. Okay? So I factored just that initial quadratic to x minus 3 squared. Is it cool? Right? X minus 3 times x minus 3. Okay? 8 minus 9 is -1. Right? Now can anyone see how, oh yeah, by the way, this guy is now in vertex form. Hello, vertex form. All right? Vertex form took me all of 2 steps. All right? This was a crazy step, though, that I bet we have some questions about. All right? Can anyone see how vertex form reveals a key feature of this graph? Can anyone tell? Lacey, can you see anything? Okay, so x minus 3 squared. What do you see there? That would give me my x coordinate. right? My x-coordinate, which was 3 for my vertex, and then -1 is my y-coordinate. So vertex form reveals the vertex for you. It's basically all it tells you. It might tell you, well, it also is a parabola that opens up, but there we have it. In a nutshell, the way that I found this 9 was like this. All right? I wanted to make what I call a perfect square trinomial. All right? I wanted a quadratic that would factor like this. I know that this original quadratic does not factor as a perfect square because it's x minus 2 times x minus 4. I wanted it to be something times itself. So I used a little formula. I took my b value, and this is a process called completing the, what was it? Completing the square in your learning targets. Take your b value, divide it by 2. -6 divided by 2 is -3, right? You with me? You with me? Take your b value, cut it in half. So -6 divided by 2 is -3. Let me try. I'm going to participate one more time. All right. So I take my b value in my quadratic and I cut it in half. So -6 divided by 2 is? Very good. -3. And then the last thing that I do is I square that value. What is -3 quantity squared? 9. All right? 9. So this is really all I need to do. I took my -6, I cut it in half, and then I squared it. I got 9. I made sure that I subtracted it as well. I have now completed the square. All right? And now I have vertex form. Now hopefully you're seeing all of the features that we have for one single quadratic in 3 different forms.